Hey everyone, I'm going to share a screen. Wait. Give me a second. Webpack is popping. Okay, so there's two classes here. Okay, one is node, the other one is tree. Okay, so for the node, you have the variable key, left pointer and right pointer. So the public is the node. Okay, at first it's -1 lah. Okay, left points to nothing, right points to nothing. -1 is default lah. Okay, default value. And then you have a private member, set key, set left, set right. So if you have to make clearer, you can change the code like this. Alright. So here basically sets the value for the node. So here goes to the left child, here goes to the right child. Here basically return the value of the node, return the left child, return the right child. So this is the class. You got constructor, you got destructor. Okay, so implementation of constructor and destructor, right? Inside the question, it's not clear. So can you change it to this? So constructor is this one here, and this is the destructor. Okay, the destructor got the tidal wave here. So inside your question, I think a bit confusing. So change to this method. Okay. So you can access the tree here. The tree and the constructor destructor is public. Obtain the root is public. Add node, traverse the tree is also public. Alright. So private is the constructor, destructor. Okay, the implementation they put under private. So you can access it through public here lah. Okay. But the implementation they put under private here. Add node and free node. Okay. Now in this code, okay, I want you to find me the overloading function. Which one is the overloading function? So I give you 1 minute. Find me the overloading function.
Is it the add node?
Cannot hear. Can you speak louder, please?
Is it the add node?
Yes, betul. Add node. So you see this one and this one here. So this actually will be invoked implicitly, okay, under the function implementation of this function add node. So add node is public. So the overloading is access to the function add node. You see add node there, okay? Else add node. So this is public. You access this add node, this one here, through the function that is public. Okay, so this one is private. You access it to this public function. Okay. So when you invoke the add node, when you want to create a new node, okay, the new node will become root. Else, that means there are other nodes really that's inside the tree. So you invoke this add node here. Now, if the value of the key is less than the left key, so the value that you want to add here currently is smaller than leaf. Okay, so here leaf here is this one here. It points to the node, the key. If it's small, you're going to add the node to, else you're going to add it to the right. Okay. Okay, so let's just go back to the code. So tree, if it's empty, root set to null. All right. If it's not empty, tree node here, the destructor, it will traverse the tree from left to right. So this is a recursive call. All right. So you do the left part first, then it goes to the right, then we delete the leaf one by one. So you delete it one by one, basically. All right. However, now first you create a tree, new tree. So tree, new tree, basically you go up here. All right. The root is null. Then you add node. So add node goes up here. Okay. Now, so the new node, which is 30 here. Okay. So you create a new node and you access set keys. This arrow here. So n set of node access set key function. So where is key? Is this one? What is it?
So I'm sorry, but I can't hear you.
Sorry, can't hear you.
Sir, can you hear us? We cannot hear you, sir.
Sir, we can't hear you.
Hello, can you guys hear?
Yes, can hear
Yes,
now.
sir.
Yes.
Oh, you're right. Okay. How are you? I don't know. I think. Oh, okay. When did I look? When did you guys stop hearing me? Here?
Around the
T.
add not part for me.
Okay. Add note, okay. Okay, so we already discussed the overloading function. Add node. Okay, so we are here, right? So add node here, there's an arrow here. Okay. So when you go add node down here, so you create a new tree. So this will invoke the tree constructor. Okay, the tree constructor here. So what is the implementation of the tree constructor? Root points to nothing. Okay, then you go to tree add node. So this arrow here means you're going to access the member add node. This one here. The implementation is under private, line 60 here. Okay. Now, it is which one it will invoke? It will invoke the first one because there's nothing inside the tree yet. So when you pass add node ni kan, 30 ni, so the key will be 30. Now, root currently points to null, so you add root node, then you add in the value 30 here. Okay. So the new node, okay, set key will pass the key 30. So this end here will access the function set key, which is under node. Here under the node here, plus node. Okay, set key 30. Key will be assigned to the value 30. Okay, and then the root will be pointing to the new node, this end here that you have just created. Okay, now if you go to tree at node 10, okay, it goes tree at node 10 kan, dia pergi kat sini. Then it sees, because the root is really pointing to the new node that you have created prior to this, so it goes to else. Okay, add another node, enter the key. What was the key just now? 10, 10. Okay, it goes 10, so it goes to this side here. Because why? Add node, pass key 30, root pointing to the previous node. So the previous node is known as the leaf. Okay, then here will be the value will be 10. Now, if key is less than leaf, which is the root, which is pointed by 30 ni, okay, you access the key. So basically when you access the key, you get the key value lah, return key, which is 30. Okay, so the key that you want to add is 10 just now. 10 is less than the key, which is 30. Okay, and if leaf here, which is pointed by root, is not null, then you're going to add it to the left side. Okay, so you're going to add it, so be 30, and then you're going to have 10. Now, if it doesn't fulfill that condition, okay, that is going to add it to the right side. Okay, so you're going to keep on adding numbers. So there'll be a case whereby 10 is less than 30. Now 20 will be less than 10. Okay, so instead of going to the right subtree, it's actually still less than 30. Okay, 10 will be on the left subtree, but 20 will be on the right, but it's still on the left subtree. Alright, so you keep on adding the nodes, then you can perform traversal in order, pre-order, or post-order order. The implementation is the same, just that the way the statement is organized is different. So if you go for tree here, okay, you access in order, then you pass tree root. So tree would access the root. So the root obviously going to access the root value. Okay. And then you're going to go, for example, in order. So you go to the function in order, you get the root. Okay. Now you see, as long as the node is true, you're going to perform left, visit node, traverse right. So traverse left, visit node, get the value, and then traverse right. Okay. So it is, if you've noticed, it is a recursive call. It will keep on recursive calling itself until n is no longer true, which is n here. Okay. It has already reached null. So n is no longer true lah. So when you reach null, then that is no longer true, and then we return back the function call here. Okay. So in order, pre-order, post-order, the only thing, all is the same. Just that different is the order. So you see here, if n is true, just that the order is different. Also for in order, it is left, root, right. Pre-order is root, left, right. And post-order is left, right, root. So that's the only difference. Okay. So you can try this program out. Any questions for this question? Okay. If no question, we go to the next question. The next question is a little bit hard. Okay. What was the question again? Okay. Write a method to calculate the maximum or calculate the maximum depth lah. Okay. So first of all, you create a node. Okay, so to create a node, so you're going to have data, and then you have two pointers, left and right. So these two are pointers. Okay. And then you're going to have name. Okay, now you're going to create the node. Okay. So the implementation, okay, so if for this one here, okay, you need to think about the logic. How do you create the longest path? Because it says maximum depth. Okay, so you're going to have basically, so depth can either be left or right. Okay, so the maximum depth would be which one is bigger lah. So you take the biggest depth. So depth of left sub 3 and right sub 3. So you're going to have a function that calculates finds the maximum depth. Maximum depth function, yeah. Okay. So maximum depth function got left side and right side. Which one is bigger? Then whichever that is bigger, that will be the maximum depth lah. Okay. Now, we also want to. So okay. In this, I'm going to share with you the answer for this question 2. It uses a shortcut method in creating the tree. All right. It uses a function that whereby the return type will be a pointer of type node. Okay. Now the size, right? The size of that is going to be used in the memory is going to use malloc, meaning it depends. So because we want to conserve the memory. Okay. So we're going to create something called a helper function. Okay. It is of type struct. It's a pointer of type struct of this type here, struct node here. Okay. So struct node, it is a pointer. The return type is a pointer. New node. Okay. It's going to receive a data because you're going to put data inside the inside the node. Okay. So you're going to have a new node, you will receive a data. So later on you call new node, and then you supply the data to the new node. Okay. So you're going to use this command. So this is basically a dynamic allocation of the node, the new node inside the memory. All right. Use struct node pointer of type node to this node. Use struct pointer node. Use the malloc size of this struct node. It depends on whatever the size is lah. Okay, so the size will be the data that you put in, and then the left and right pointer. All right, and then from this pointer here, okay, you'll be able to access the data. That means you enter the data. So here is, for example, here is the data, right? So you use node data. So node access data will be assigned to this particular data. All right. So when you create a new node, left pointer points to nothing, right pointer points to nothing. Okay. So what do you return? You return this node that you have just created. Okay. You supply data. It reserves the memory size. Okay, and you put in the data. Node left points to nothing, node right points to nothing, and then it returns this node to whoever calls it lah. Okay. Okay, so you have struct node. Okay, the maximum left I haven't do. Okay, so if we say struct node, okay, so node is a pointer, and we give the name root. Okay, so this is struct node, okay, of type pointer for root, and then we ask it to add in new node 30. Okay, so 30 here receive, it will create, it will point, sorry, it's going to create a size inside the memory to accommodate this data left and right. Okay, and that is going to put the data as 30. First is 30 here. Okay, node left points to nothing, node right points to nothing. Okay, and then you return a pointer to this node. Okay, so you return it to the, so you return this node, this one that you created. Now this root points to this node with the value 30. Any question? No question here? Okay. Okay, so this data here you can change lah. So now if you want to put the root left, okay, left child as 10. So you go, here we got root, this pointer points to this this new node, root pointing to this new node. Now when you type root point access left, then you see I'm going to add in a new node at the left side as 10. Okay, so root here, okay, you're going to access the left function, you're going to access the left member, okay, and then you're going to say left points to a new node. Remember, got data 30, got left, got right. Okay, you access the left, this one here, and then you say the left now points to a new node. So this new node you create again, you pass the value 10. So the data here is 10, this new node 10 ni yang you baru create ni, left, right points to nothing yet. Is that clear? So when you put new node, another one, new node right, root right, new node 40. So this root here currently points to this new node that you just written. The right pointer there, this right pointer points to this new node that you have created, which is 40. So this new node, left, right, points to nothing. Now, if you do root left, okay, it points to this new node. But this new node 10, right? Its left points to what? Rebecca.
Sorry, sir. Can you repeat the question?
Pardon?
Sorry, sir. Can you repeat the question?
Okay, root left, okay, root left here points to this new node that you have just created, right? First you create 30, then you create 10. For left, the newest one for the left side is 10, okay? The newest one for the right side is 40, okay? Now, my question is, when I do root left, okay, I do root left. Now, this root left points to what currently?
Now?
No, belum lagi null. Still pointing to new node.
Oh,
But if I put root left, now it points to what?
oh. Now
Wait.
baru now.
Betul, now baru 6.
Oh,
Okay? Tapi bila I cakap root, okay, now root left, and I cakap this one. Now what is this left points to now? Currently it points to what? Now.
4.
Huh?
Now
Now it points to where?
it points to 4.
Huh?
4?
Points to 4, betul. Ya, pandai. Okay, good. I ingat you cakap 2 tadi. Okay, betul. 4. So you faham? You guys faham tak beza tu? Ada perbezaan ya? Root left ni points to null. Currently. Bila I buat ini, now it points to the new node with the data 4. Faham tak? Guys, okay ke tak? Who got a question? Please ask me.
Okay.
Okay ya? Sure not? Sure? Dayang? Okay?
Okay, sir.
Okay. Okay, kalau okay, Dayang, ini point kepada apa?
New node. Nothing.
Root, left, right. Okay, so root, left, point pada new node. Okay. So sekarang ni, root, left. Tadi saya buat root left, dia points kepada null. Sekarang, dah tu root left points kepada new node. So root, left, right. Dia points kepada apa? Null. Kalau root, left points kepada apa?
4.
Betul. Very good. Okay, good lah. You dah faham kan? Okay. So root left, right, saya letak the value as new node 20. Okay, very good ya. So I think you guys dah faham. So ini just data. So apa yang saya paste lepas ni hanya data saja. Yang penting you faham the root left, right tu saja. Okay? Alright, ini semua ni adalah data saja. I'm just putting data, okay? Now, baru saya akan buat the maximum depth. Okay? So ini saya just copy paste. Print height of 3 is, now kita akan create dia punya max depth. So yang ni. So, maximum depth ni dia punya return type apa you rasa? Kita nak cari dia punya depth kan? So kalau you tengok lecture note tu, depth tu return type dia apa? Apakah type of depth tu? Data tu jenis type dia apa?
Integer.
Integer, betul. Okay. So let's just give the the name. Integer max depth. Parameter tak buat lagi. Open close curly braces macam ni. Okay. So, bila kita nak cari max depth, okay, kita nak cari depth dia kan, it has to start from the root, betul tak? Root pergi level 1, level 2, level 3, whatever level lah, betul tak? So, kita akan pass dia punya root. So, root ni apa jenis dia? Type dia. Dia adalah pointer. Okay, pointer dalam what is the type? Struct node. Okay, so copy struct node. Okay, so nama dia kita dalam local variable dia adalah node. Nama dia je lah. Okay. Okay. Any questions regarding this one? Okay, so bila kita okay, so bila kita when we want to find the max depth, so we need to know there is a left subtree on the right subtree. So when you want to find the maximum, what does it mean? So you got left and then you got right subtree, right? So the maximum means there must be a comparison lah. If left bigger than the right, okay, then you return left, right? Else you return right. Betul tak? If left bigger than the right, because you have to find maximum, right? So you return left, else you return right. Okay, so you must ada comparison left and right tree, select maximum. Okay, so bila you go from depth 0 to depth 1, okay, so you go to depth 0 to depth 1 in the left subtree. Okay, so you go from 1 depth, what do you do? Depth 0 to depth 1. How do you differentiate between depth 0 and depth 1? Macam mana nak buat tu? You transition from one depth to another depth, what must you do? Rebecca, any ideas? So, katakan depth, mula-mula you dekat kosong. Okay, kereta belum bergerak, you dekat tempat kosong. Kereta bergerak, you dekat Kuala Lumpur, which is 1. Okay, so what is the transition there? When you bergerak, you add in 1, betul tak? So when you go from depth 0, you go to depth 1, you add in 1, betul tak?
So, increment?
Okay, something like increment lah, betul lah. When traverse depth increase 1, okay? So we have comparison, and then we have traverse depth. So when you traverse depth ni, in order to increase 1, from depth 0 to depth 1, you increase 1. Depth 1 to depth 2, you increase 1. 3, 4, 5. So basically, you must have a place whereby you store the value of the depth. Betul tak? You need to keep track, You need to keep track. So you must have a variable, basically, that keeps track the depth. So either L depth, or left depth, or right depth. Okay? This is the value that you're going to return. So depth, as you know, is an integer. Integer. Okay, starting 0. Okay? So when traverse increase there by 1, you compare left and right tree. Okay? So, what are the scenarios that can happen? So, scenario dia, if there is nothing in that tree, you return nothing lah. Depth is 0 lah. Kan? So, this guy, if there's nothing inside the tree, then the depth is 0 lah. Okay? So, you pass a node, you pass the root, okay? So, you create. If The root here is known as node. If currently the tree node value is equivalent to null, then I will return this def basically is going to return kosong. Betul tak? Katakan tree tu kosong, dan return kosong lah. Tetapi if tree tidak kosong, if tree tidak kosong, then I am going to traverse and compare. Okay. So sekarang ni, how would you traverse the tree? So bila you traverse the tree, you nak cari depth, you akan check dekat bahagian left, and then you akan check dekat bahagian right. So andai kata you traverse bahagian left dulu. Okay. You traverse bahagian left. So should be traverse left. Okay, so how do I traverse left here? Integer data node left, right. Traverse left means going to root left, 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 left. So if I want to traverse left, then the value of L depth, ini I nak traverse dulu ya, I nak dapat the value, okay, is on traverse left, right. So I go back, what do? I have to go back inside the tree. Alright, I go back to the inside the tree and then I go left only. So node is the root. Okay, node is the root. So this is the root, this is the node lah. Okay, so this particular, I'm going to start from the root. Okay, I'm going to go to the left side of the root. So how do I do that? I dah pass root. So I just panggil max depth. Okay. The node, which is the root, I traverse to the left. Okay. So I pergi balik di atas. And then I keep on traverse to the left. So I traverse until the left. Okay. Until what happens? I reach null. Okay. Then after I traverse left, I have to traverse right. Okay, traverse left. Then I will think about traverse right. Okay. So imagine root. Okay, you dah pass dekat root. Okay. Sekarang ni root. Lepas tu dia pergi kat max depth ni. The root is node left. Node ni dia pergi left. So it goes to the next node. It's no longer the root, but the next node after root, it goes to the left child. Then the left child will go to the next left child. And this is a recursive function. Okay. So you're going to go to the left. You keep on going to the left. Okay. Until the left is null. Okay. And then you're going to return 0. So tak, you pergi left, 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 until dah tak ada apa-apa. But this is a recursive call. Okay. So this recursive call, you go to the left. Now you return 0. Okay. Now, if you return 0, it goes back to the previous recursive call. Okay. Now, what happens at the previous recursive call? What do you do? Okay. This one I want you to think. I give you 5 minutes to think. So we haven't finished traverse right. Traverse depth increased by 1. Then comparison. So I give you, you try for 5 minutes. Okay. How to complete the code. So, remember, yeah, this is a recursive call. Then at one point it will stop. Okay. And then it goes back to the previous recursive call. Okay, I give you 5 minutes, yeah. Okay, to help you, I suggest you draw a tree, binary search tree, all right, with the root is 3. The number entered is 1, 2, 3, 4. So on your left sub tree, you're going to have the value 3 as a root. The children on the left will be 2. The right child will be 4. For the child of 2, the left child is 1. You use that tree. Use that tree to finish the code. So what would be the logic be here? So that figure, okay, is depth also. So the depth 0, then will be depth 2, 4 will be depth 1, and 1 will be depth 2. Okay, by the way, the question here, the number of nodes along the longest path from the root to the farthest leaf node. So it's counting the number of nodes. So look at the question. If empty tree is empty, return 0. Max depth is actually the number of nodes that you're going to traverse. So you see, if you go from the root 3 and you go to the left child, katakan you masuk left child 2, okay, which we are doing here. Kita tengok kat sini, left depth, maximum node left. Okay, so here we go to. So we're going to calculate left and right, right? So you also have to give the value for R depth after this. Going to compare the tree. Just that for R depth, node is right. So we're going to go level by level. And then we're going to calculate, when you go level by level, you traverse, okay? You traverse left, then you traverse right. Then every time you traverse, you're going to return a value by 1, increment by 1. Okay? If node is null, eventually you will reach null, you return 0. But this is a recursive call, remember, yeah? So you traverse left to right, 2, and then 4. So if you go L depth, so you're going to return, okay, at one point it's going to reach null, then it returns back to the recursive call, okay, either left or right, whatever it is, before it reaches the node before it reaches null, it will return the value 1, right, for both L depth and R depth. So here, whatever it is, it will return 1. So you have depth, left depth, and you have right depth. Either one, L depth is going to be increased by 1. R depth also will be increased by 1. Okay, then R depth. So we traverse left, we traverse right. Okay. At one point you will reach null, then it returns back to the calling function. Okay. So at that particular left depth, it will increase by 1. At that particular, if it's at the right depth, it will increase right depth by 1. Okay. So now we're going to have 2 parts here. Now, when you compare less subtree, there can only be one winner. Which one that is the largest lah? So there's going to be an if and else. So this is where the comparison comes in. Okay. So there's going to be an if condition. And then there's going to be an else condition. So you see, if the code, if the tree use is 3, 2, 3, 2, 4, 1, 1 eventually is going to point to null. It returns 0, it goes back to 1. 1, then it will, because it's a left tree, so it's going to, from 0, okay, from 0, it will plus 1, so it becomes 1. 2, it becomes 2, and 3, it becomes 3. Okay? So if write 3, it will only have one node. So you need to compare. It doesn't matter whichever way you compare it. If L def is bigger than R def, you return left def. Else you return R def. Okay? Oh, node right. Right def was not declared in this code. Oh, okay. Okay, new node was not declared in this code. What do you mean didn't declare in this code? Let me see. Okay. Oh, let me check the code, yeah. Second. Stop new node.
So I think the new not spelled wrong.
Oh,
It's supposed to be the nots and is
yeah.
capital.
Satu balik. Okay, yeah. Okay, so height is 3 is 5. Okay? Any questions? So you traverse. So remember, you start with, because it's a recursive call, okay, you eventually terminate. Okay, then it goes back to the function. Whenever it goes back to the prior call, you increase by 1. Either left or right. Then you make a condition, whichever lah. It could be if right def is bigger than left def, then you return right def lah. Doesn't matter. Okay, then it would supposed to be able to calculate the def. Okay, any questions? So only this one is the adding of the data, yeah, not given inside the question, but you can put in any data lah actually. All right. So if no question, that is all for today. For the group that have lecture this morning, please take your attendance for the lab. Those who got class at 4, no need to take attendance anymore lah. You already take sekali lah, you ambil attendance, yeah. So please take this attendance for group 5. So I understand that someone want to ask a question for project this morning. Can you ask the question now, please?
Okay, so
not you, Rebecca. Wait, follow someone now. Was a guy, right?
No, he's in my group also.
Oh, okay, all right. Okay, then you can ask.
Want to ask that for the project, the add node part, is it possible to implement this binary tree into the stack and linked list thing?
That one you have to think for yourself.
Is it if we somehow, someway find out a way we can use binary tree lah.
Yeah, can.
Okay.
Please read the question, yeah. And and please read the question and read the rubrics.
Oh.
Okay. So that one you have to think for yourself. Please read the question and refer to the rubrics. Okay, next question. No question, only that. Okay, refer to the rubrics, guys. Skema pemakahan tu. If no question, that's all for today. You still have one more class with me on graph, okay? So please check you punya. Oh, by the way, next week, still holiday on Monday. So those with you on Monday, can you come to class lecture on Tuesday, 10 to 12? Can,
Sorry, sir, can you repeat the question? I didn't hear it just now.
Those with class on Monday, next week Monday holiday, can you come to class on Tuesday, 10 to 12?
Yes. Can.
Yes, everyone okay? Group 5? You group 5, right? Yes.
Should be okay.
Should be okay, yeah? Okay. So I'll see you guys next week on Tuesday. But please read the announcement on ELIP. Okay, if no question, that's all for today. Please take your attendance. Happy Gawai and Keamatan to those celebrating, yeah? Okay, take care everyone. Bye-bye.
Thank you, sir.
Thank you, sir.
Welcome, bye-bye.
Thank you, sir.
Thank you, sir.
Excuse me, sir.
Yes?
Sir, I haven't taken the attendance for group 6.
Why you haven't taken attendance?
Because I thought the class start from 5:50, then I entered the class by 4:43 like that.
Yeah, same, sir.
So you entered the class what time?
4:03.
Oh, okay. Wait. Okay, wait now.
Okay, sorry, sir.
Okay. Hello. You give your name on the chat, then I do manually lah later.
Okay, thank you, sir.
Okay, you give chat now. Put your name in the chat now.
Sir, including me, sir.